That seems to be on. Okay. Hello, everyone. How you doing? My name is Aaron, and I'm working here at Go210. So I just want to give a big warm welcome to you all for attending tonight. I'm so glad you could all make it out here. So a little bit, I'm working here, Go210, and it's by this crowd here, as you can see, Internet Stiftelsen, the Internet Foundation of Sweden. And what do? They are providing a space like this to have people come together, to meet, to share knowledge for skills development. And it's also a way to kind of bridge those gaps between the academic world and also industry. So it brings together many different groups of people to share in their interests, their ideas, whether they want to share their projects or they just want to meet and mingle like you hopefully all came here to do tonight. So that's why it's called LaunchPad, and I came up with the concept of LaunchPad myself. LaunchPad was very much inspired by working here at Go210 and meeting lots of people, talking to lots of people, talking to companies and talking to students and finding out what are the interests and needs that they would like. So that's how I came to start LaunchPad, to bridge those worlds together. So that's why we have not just students, but we also have companies, or for small companies, large companies, freelancers. This is a place for everyone, and it's really a place for you to be able to share also and be able to be part of a community, which is kind of what inspired me to do LaunchPad, is to create a community here. And it's I am so glad that you came tonight, and I just want to tell you, give you a heads up a little bit about the program we have tonight. In total, we have four presentations. First of all, we're very excited to be joined by Saab, who's going to be talking and presenting some knowledge for us today. And we also have Casper from Lite Code. Where is Casper? Is here. Hello Casper. And he's going to be also presenting for as well. So we have the student representative here as well, and the companies, and we have all of you. So we are complete. And after presentations, we will be having pizza and mingle session. So please stay for that, because that is the most important part, really, is to meet people and to grow your network and just to have fun with each other. We're all equals here, so this is not a formal recruitment fair. We are here to learn from each other and share. So that's it for tonight. If you have any questions, you want to speak to me, if you want to become a member, I'm here for you. And I also have my colleagues, Christina, who's handling the live stream tonight. A big shout out to people online. Please also, if you have questions for our speakers, please write them in the chat. And also for here, I will be handing out the microphone for questions as well. And we also have Uli, our boss community manager here. She is running the place, and she is also available. If you want to ask her questions, she will be very happy to do that. Is that right? And just to note, we will be doing some short reels as well. And also, when we're having questions, I will pass the microphone around and need to speak clearly into the microphone so we hear. So that's, without further ado, I'm going to introduce our first guest speaker, which we have Olof Sundin, who is the Director of Software Strategy at Saab Aeronautics. So a big warm welcome to Olof, and the floor is yours.
Thank you very much, Aaron, and thank you, Go210, for letting us host this tonight. It's very nice to be here, meet all of you. Like Aaron said, I used to be a software developer for many years, but my title is now Director of Software Strategy. And from that you can tell that I will be bringing you the fluff and the you know, and the hardcore stuff will come later. So, okay, so I'll just give you an overview of what it's like to work with software in a jet fighter and what the role of that software is on a high level. Okay, and I won't be. And Aaron has promised to interrupt me if I speak too long. So, okay. But of course, you're free to ask questions and so on, and we of course will be here afterwards as well. Great. So let's go then. And this is the agenda. I will talk about Saab Aeronautics very briefly. What's that? And then a short history of Saab Aeronautics, and then the role of software in the fighter, some of the challenges that we meet, and some of the stuff we have to think of that maybe you don't usually have to think of if you're a software developer. And then a little bit on what's next, what's in the future. So, okay. Saab Aeronautics. We build these kinds of machines, mainly. We're one of 4 business areas at Saab. Okay, so the thing we have in common is that we are a defense company. So we have aeronautics, which is us. We have dynamics. They build smaller things that you can carry around. Mainly, we have surveillance. They build radars and sensors and things like that. And then we have Kockums, and they build ships, surface ships and underwater ships. Okay. Saab was founded in '37, and the first division was at first it was airplanes. So aeronautics is like the original Saab. Aeronautics has almost 7,000 employees, I think now. And we have 4 business units at Saab Aeronautics. We have advanced programs. They look into the future, what's coming after the stuff we have today. We have aerospace systems. They build things for mainly things for the civilian industry, but also some contract stuff and collaborations with the Boeing, for example. We have aviation services. They serve our aircraft and other aircraft. So aftermarket and maintenance and things like that. And then we have Gripen. And Gripen is the business unit that builds this, which is our main product here in Linköping, Gripen jet fighter. And we're based here in Linköping, but we also have mainly we have business or plants in Brazil and United States. Okay, so that's Saab Aeronautics. That's all I was going to say about that. So, brief history. This is some of our aircraft that we have built throughout the years. Like I said, we started in '37. We built this, which was basically a copy of an already existing aircraft. You have to learn to crawl before you can walk, right? And then we built a lot of aircraft in the coming 30 years. We built one called Viggen up here, which you may have heard of. We built the Flying Barrel, which was the first, the fastest plane of its time. But suddenly, then we built Gripen in the 90s. And as you can see, we started building it in the 80s. And all of a sudden, things seem to have slowed down, right? Here we basically built a new aircraft every 3 years. So what changed here? What do you think? What's the reason for this? Why are you here? What's our common interest? Software, right. Software happened. All of a sudden, you didn't have to build a new machine if you wanted to add some functionality. Okay, if you built this carefully, you can upgrade it and add new functionality. That's what happened. So innovation didn't stop, but innovation moved into software. So Gripen E is quite different from what A used to be, but on the surface it looks very similar, same wing configuration and so on. But of course, if you look inside, it's different. Of course, this followed the trends in the mechanical systems at first, and the trend, of course, moved over to electronics. You got computers, some around here. This was actually a Saab computer, the first one. And then the computers became small enough that you could put them in the aircraft. So this was the first aircraft with a computer. Things moved on. you could have one box with several functions after a while, and now you can have one box with several computers on. So it's the same as you can have in your home. And this, of course, opens even newer opportunities. And what will be next? Well, we'll talk about that in a while. And this follows, of course, a general trend in the society and how technology has evolved over the years. So functionality has moved from mechanics to electronics over to software. We have learned that we can collect massive amounts of data and store them, and we can use that to make new functionality. Artificial intelligence has been around for a while, but it's now much more useful. And then something else will come, okay? So I don't think anyone objects to this. Makes sense, right? Okay, so let's move on to the fighter then. Back to the fighter and software in the fighter. That's what we're here to talk about mainly. We have a few challenges when we build software for an aircraft. What's this? Does anyone know? You recognize it? Yeah, it's a flying wing aircraft. Have you flown in one of these? No. Anyone else? Oh, that's because no one has. Not in this kind of flying wing, at least. Because it's a concept. But this is how engineers have wanted passenger aircraft to look like for years. To be, you know, aerodynamically good and so on. What's this? Well, you have a hint here. This is an actual jetliner. Quite modern. And what's this? Anyone? Do we have any aircraft nerds here? This is the de Havilland Comet. It's one of the very first jet-powered passenger aircraft. So this is from the 50s. Isn't it interesting, though, that these two have much more in common than this one? And this is how they were supposed to look like, right? So it's a conservative business. This was a computer, I talked about that before. And this is also a computer, right? It's not even a modern one anymore. But it happens to be from the same year as this aircraft. So there seems to be a lot of rapid development in the computer business, right? Not so much in the aircraft business. So that's one challenge. We have to keep up with the rapid technology that goes on down here, while at the same time keeping in mind that the aircraft industry is quite conservative. They want things to be robust and work and be reliable. Another challenge is this: if you want to write software for an aircraft and you want it, or for a vehicle, and you want possibly some monitor functionality, right, to see if anything goes wrong. So let's say you're building that for a car. So this is what that could look like. It's a good fail-safe system. Everything okay? Yes, keep going. No, pull over. Should be sufficient, right? Unless you build a flying vehicle, because then it's more difficult. So basically you don't want your software to fail. So that's another challenge, of course. And the third challenge has to do with this. Building an aircraft and fighter is not actually the hard part. It's not manufacturing all the different parts and machinery and the computers and so on. That's difficult as well. But anyone can do that if you put enough effort into it. This is the hard part. Putting it together in a small machine that is super hot inside. It has a jet engine inside. On the outside it's minus 60 degrees Celsius. It goes at the speed of sound. It's vibrating and so on. So that's the difficult part, not this. And also, at the same time, integration has moved gradually from hardware to software, as it has in most industries, right? So you no longer connect your radio to a physical button in the cockpit, perhaps. You connect it to a computer, and then the computer decides which button activates the radio. So integration is a difficult challenge. And integration, how hard can that be? Has any one of you bought something like this from a furniture store? I'm sure when you got home and unpacked it, it didn't really look like this, did it? Oh, it looked like a bunch of boards and stuff. Have you tried to assemble it without using the instruction? So how did that work out? Not really, no. Because it's difficult. And why is it difficult? Because the order in which you assemble it matters, right? It's really, really important. And if you build something like this, it's even more important. Unfortunately, when you build a fighter aircraft, you don't have this, because you're developing something. Making this is part of the development. So it's even more vital that you really consider the order in which you put things together and so on. And it can be hard to integrate things. Even simple systems can be hard to integrate, because you can have subsystems that block each other, or you can have interfaces that don't really match, right? You can have subsystems that affect each other in ways you didn't really consider. These are all very, very simple systems, but there is room for error anyway, right? Okay, so we have to consider this when we build software for a fighter, and that's reflected in the integration architecture. So if you look at this picture again, this is the basis for how we do our software. Like I said, aircraft's industry is slow, conservative, but we really have to develop software fast. And the way to do that is to try to divide it in two parts. So we have all that's safety critical, everything that has to do with the engine and fuel and breathing and giving oxygen to the pilot and so on in one part of the system, and the things that make it a fighter in another part of the system. You know, controlling your sensors and weapons and things like that. On this side, you want to take advantage of the rapid development in computers and software, so you need powerful computers. You want to upgrade them. On this side, you want them to be robust and always work. And also, if a customer comes and says, I have this fancy weapon, I want that to be integrated. Yeah, we welcome that, because the system is built like that. We have considered that. If they say, well, I want the engine to work in another way, can you change the software? We will not be as happy. And if they say, I have an engine of my own that I want to integrate, then we'll be really sad, because that part of the system is not made to be changed very often. Maybe once in the lifetime of a fighter. Okay, and of course we use, but we use a service-oriented architecture in order to separate these things from each other. So you can do whatever you want here. You can use services over here to get the position of the aircraft and things like that, but you cannot really affect anything on this side. So the tactical system can break down and that screen can go black. Well, you won't crash at least, because this part of the software will still run. So it's basically like a smartphone setup, you know. You can add apps and so on, but you don't want to mess around with the underlying operating system and so on. Obviously, this was the aircraft. Obviously, we have software in many places. We build systems for maintenance and so on, and that's also software today, not papers anymore. We build mission planning systems, you know, for the aircraft and other things. We build simulators for different purposes that you use during development, or that you use to validate, get early validation of a concept and so on. Obviously also software, and we build advanced training systems where you can train even a group of pilots and operators. So there's software all over the place at Saab Aeronautics. So what's next? I promised to tell you what's next. What's over here? I'm sorry to say I don't know. I hope I didn't disappoint you, but we can look at some other people, what they say, people that are wiser than me, or bolder at least. For example, Volvo, Anna Sandberg, who is head of continuous improvement. She states that 95% of all future innovations in the car will be software related. Okay? So not all innovation at the company, but in the actual car, 95% will be software related. And there is no reason for us to think that it will be any different in a fighter jet, right? So I think we can safely say that software is important in the future as well. Also, the US Department of Defense, the impact of AI is comparable to that of aircraft and computers. Wow, what are they really saying here? So the battlefield will be affected by AI, at the same magnitude as it did when aircraft turned up for the first time. Okay, so AI seems to be important as well. Also, this has happened. You know, Sweden have joined NATO, and there's a war going on in our vicinity. And this war has also opened the eyes of many governments and the defense industry that, okay, maybe we need to be more faster when we develop things and be able to update them more rapidly and so on. So we will see more of that in the future as well. Okay, so what about software transformation? And this is AI and so on. And actually, software is also becoming more and more to the left in this picture. As we add more things over here, it will go to the left, so it will become a commodity as well. What we have to do, well, functionality moves in this direction. It will continue to move in this direction to something else. So what we need to do is add resources here as a company, and all of you other companies also need to do that, of course. But we cannot just add resources here without taking away resources somewhere else, right? Because we will just grow and our products will be super expensive. So we need software transformation is absolutely vital for two reasons. We need to add new technology, new business opportunities here, but at the same time, we need to use new technology to increase productivity here, so that we can do the same thing with fewer people. Otherwise, we won't be able to do this. So actually, that was all I was going to say. Any questions or comments? Yes?
Okay, I think you were first.
Thank you for giving the presentation, first of all. My question relates to the splitting up of functionality which you were speaking of. From being a bit interested in this, I know that you tend to want to have the planes be quite aerodynamically unstable to make them handle very rapidly. And this is obviously quite important to the military strength of an airplane, like a fighter. So how do you handle a case where you have a critical system such as handling and stability that also needs to probably evolve quite rapidly?
That's one of the systems that we don't want to evolve rapidly, I can tell you. Of course, there are iterations in the flight control system as well, but basically that will not change very much. Instead, we want it to be flexible enough so that you can add more weapons and so on, and the flight control system will recognize that, and still you will still be able to control the aircraft. So I think that is the answer to that question. And of course, there are, I mean, triple, the reliance of that system is super high. So you rely on that system a lot, even if you can eject as a last resort. So everything is tripled and so on.
Thank you very much.
Okay, maybe we should move on. Aaron, what do you say? Even if there are more questions, they can try to look me up afterwards, right?
Yeah, I think so, and you're going to be here, so
yes,
they can just ask you. Okay, well, thank you, Olof.
Thank you.
Okay, and now we have our next presenter, and we have Michaela, who's going to present to us. Welcome, Michaela.
Ja, precis. En dator. Tack. Åh nej. Okay. Or maybe I should plug this in. Okay, so now we will actually talk a bit more about the future and what's coming next. So I will talk about a research project that was started last year. Yeah, we will take it from the beginning. But just a little bit about me. So I have studied here in Linköping, the Applied Physics and Electrical Engineering program, the Y program. Is anyone here from that program? No? Yeah? Okay, yeah. Yeah, I went to that program and I chose the Master in Applied Mathematics and thought that optimization was really, really nice. To be able to solve really large problems with mathematical methods and yeah, to get a solution really quickly. I really like that. So I started at Saab 2 years ago and belonged to the Aeronautics business area and the Gripen business unit. So I have mainly been working on software development for Gripen, but also things related to avionics scheduling. And that is not scheduling of staff or something like that. It's more like scheduling of activities in aircraft computers and when to send things over networks. And that is optimization problem. And I've also been doing some project leading and been involved in this research project. Yeah. So what is avionics? We have, as Olof mentioned, we have a lot of computers and software in the airplanes, and those are part of the avionics systems. So we have the sensors that gather information, we have the compute units where information is processed, and actuators and displays so that the pilot can see what's happening. And there's a lot of information in the avionics system that is continuously updated quickly. So there's a complex data flow between these different units. Avionics systems are hard real-time systems, so it's really important that things are correct. And you will hear more about this in your presentation, about common programming mistakes that we don't want to do. But it's also very crucial that things happen at a specific time. We don't want any delays in the systems. So it's not enough for things to be correctly implemented. And one way to assure this is to have a spatial and temporal partitioning in the system, meaning that we allocate a region in both in memory and in time to a specific application. And in that way we can assure that when a specific application goes down, it doesn't propagate errors to different parts of the system. Yeah, so the temporal partitioning part we can solve with scheduling of an avionics system. Yeah, and much of the capability in the modern fighter systems rely on functions that are realized in software. And this will not change in the future. So I agree what you said, Olof. So if we take a look into the future, we see a substantial increase of these functions and also an intensified interconnection between these different functions. And potentially autonomous operation of platforms. And also the utilization of heavy data fusion, algorithms and AI technologies. And this is this would be really nice to have, really cool. But it leads to a huge increase of data to transmit over these networks in the aircraft. So we need to prepare for that. So future avionics systems need to be, first of all, really high performant to be able to send a lot of data between different units, have a lot of computing power and so on. But they also need to be flexible and adaptable so that we can adjust to different updates and customers and yeah, if we want to do changes. They must be able to, they must be scalable. since we expect so much functional growth in these systems. And also standards compliant, it's is good to have, so we don't have to develop everything by ourselves. But how do we achieve these nice properties? Well, we think that it would be good to use a modular architecture, for example, an EMA architecture, which is an modern architecture for avionic systems. And also virtualized hardware to a greater extent, and also the support for established standards, such as time-sensitive networking. Have you heard about time-sensitive networking? No? That's we're not the only people looking at that technology. It's one of the key technologies for enabling Industry 4.0, the fourth industrial revolution. And it's a network technology that can handle really large streams of data, but also handle real-time traffic. And usually you have to separate those kinds of networks. So that's a really good networking technology. But if we want to realize a system of this kind, we must solve some difficult problems. We have to configure this system and decide where different applications should execute, how virtual machines should assign cores to virtual machines, and schedule the network. And these problems can be really, really challenging, actually. So in this research collaboration, we aim to develop methods for solving these kinds of problems. So currently we are 7 people working in this project, and we have one PhD student, one industrial PhD student. And now we're looking at this time-sensitive networking technology. How do we schedule those networks and decide how to route traffic in the architecture? And if someone here is looking for a master thesis project for this spring, we have an opening this spring that's related to this project. So come and talk to me if you're interested. I can really recommend it if you like mathematics. That was a brief overview of this research project. Do you have any questions?
Questions? Okay. Well, thank you, Michaela, for your presentation. Thank you. And you also be here so they can chat to you.
Don't hesitate to come to me.
Perfect.
And talk.
Okay, great. And our next presentation, we have Joachim and Andreas. All right, welcome. I need to get your headset.
So let's see if mine is on.
Now it's on.
Oh, does anyone recognize the title? We stole some from Olof's presentation. So we're going to talk a bit more about the software. So this is when this is not an option. It's briefly. I am Andreas, and I'm from Värmland. And I studied in Karlstad. I moved here after I was done with the studying in 2013. And I've been working at Ericsson and at Saab.
I'm Joachim. I'm also from Värmland, but I didn't study there. I came to Linköping to study aircraft. I've been working in teaching, and I've been working at Siemens and now at Saab for almost 3 years. And we both work in navigation. Andreas is in Gripen E, and I'm in Gripen CD. the older version which is used by the Swedish Air Force right now. And we're developing anything that has to do with position of the aircraft, altitude, speed, acceleration, attitude, and we're doing that by the equipment, the hardware, GPS and INS, radar, altitude,
altitude, radar altitude, and radar is short for something I'm not sure of. Maybe you know that. So it's short of something else that is short, but
altimeter, radar altitude, altimeter.
So it's a way of knowing which altitude you are at by using radar.
Yeah.
By the way, do you know it? Before you could ask questions. Now we will ask you questions.
Yes.
So do you know what INS is? And why is it on the same line as the GPS? Yeah, exactly. So it's when you don't have GPS. So then it's it can somehow censor where you are and where you're going.
Yeah, it's the dead reckoning part. And specifically in the Gripen, we have joined those two, so we have a sort of blended position. We're combining the GPS with the INS in order to reduce the influence of the drift from the INS. And also we have the ADS, which uses the pyrotubes. It's an air data computer. And we also have alpha and beta sensors.
Are they on this one?
The alpha and beta sensors are keeping track of if we're banking or pitching. And this is the pyrotube. It measures the pressure, the dynamic pressure and the static pressure.
We kind of have tiny wings next to the airport. It's outside the airplane that feels if you're going upwards or downwards. Because that one will, yeah, the wind will take care of it to move it around. And also if you go, well, turning like this. Short, what we can say here is that if you want to go working for Saab, you should definitely go to navigation, because we have so many cool functions and so many equipment, and we have pretty much all this chain. We do pretty much everything until the screen. We know nothing about that. We can tell people at the HMI that okay, we have this speed, please tell the pilot, because we don't know how the pilot wants to see it. So all these things, that HMI takes care of that. Yeah, now we go on to talk about the software. The first thing we always think when we have a function. Maybe in the beginning, like when I started, then we haven't been flying yet with the Gripen E. Then it was so many basic functions. Now we have some changes also in those, but a lot of things that the pilot thinks is cool. But then when he has a function or she, then always you think, what will go wrong if this does not work? And if you look at some other airplane companies some years ago, they did not think about that perhaps. So Joachim found some nice pictures here illustrating that maybe it's a little bit more important that things does not go wrong here than on here. Yeah, do you want to add something? Or should we just yeah, what we have is flight critical and mission critical. I think next slide, right? We stole a picture from Olof again.
Yeah, we did. Just to clarify, this is the flight critical. If something goes wrong here, you're dead. Here it's just a slight inconvenience.
Or you just what's called, you pull yourself out from the airplane. But this picture, we stole it and we added a little bit. And this is where we come to the flight critical or not. If it's flight critical, yeah, then we're here. But some nice features we have is just that, okay, we cannot do our mission, but we can go back. So, yeah, but also we think of how can the things go wrong? Like how often does the equipment fail? And what can go wrong with the software? That was actually the reason why I wanted to start at Saab. I didn't really care much for flight airplanes. Now when I've been working here, I really like them. But in the beginning, I just like coding. And I wanted to know how can I make programs not fail. Like if you open your phone and you open your app, and then it it crashes. And you restart and it crashes. And that was the opposite of what I wanted to do. Yeah. Also, we had to think of is that sometimes you don't get any information, and then at least the pilot knows that, okay, I don't know the speed or whatever. But if you have misleading information, it can be actually much worse. So let's say you think that you are on a nice altitude and have your attitude going straight, but the reality is that you are very low and your attitude is going down. So misleading information can actually be much worse than no information.
Yeah, and that's depending also what the pilot is doing right now. If you're going in to land in cloudy conditions, misleading information could kill you quite easily.
How many are programmers here, by the way, or likes pro? Nice, lots of you. So we said that this is not really commercial for Saab or recruiting event and so on, but we still want to just make one really nice thing about working with coding in Saab is that we have all these different roles. Like usually you have a software developer and test developer, of course, and team leader. So if you want to make a career as a programmer, of course you can be a team leader, you can be a project leader, and manager of people and so on, line manager. But very few programmers want to do that. The most people just want to code and be better at coding and know the quality, make sure things working perfectly and so on. And at Saab we actually, since we're working with aeroplanes, it cannot fail. So for each application we have a quality manager, and that person can say nope, stop, and then we stop. I mean, we're not allowed to go continue. And then for each material group, as we call them, like navigation or engine or HMI and so on, you have one that is quality manager for the entire group. And that one says, stop, this is not good enough, then you stop. If you're making an application for your phone, I'm quite sure they don't have these people. Maybe they have them, but that's just on paper. When they say stop, the project manager will say, no, we want the money. And here, that's not an option.
Yes, and then you also have, if you want to continue after that, you have the chief engineer, who's responsible for a larger part of the aircraft, and also software quality assurance manager on a higher level. So those are the people that go to jail if we do something wrong and the aircraft crashes.
Okay, so here's one of the, I would say, most important things, or maybe the most important thing when it comes to making software not failing. And if you ever go to a thesis, defending a thesis, and you're in coding, one question you can always ask on whatever level, you can go on a new professor telling what he's been doing his research on and so on. You can always ask, how are you sure this is what you actually tested? I was a PhD student in Karlstad, and and I was doing all my algorithms, like mathematics and networking. I think they were perfect, and I made so much tests on this, and I think that was perfect. But if someone would have asked me in the audience, like, how do you know this is actually what you tested? No idea. And lots of people in the company has no idea. And that is the really main thing on Saab. I mean, you have to make sure that what you actually want to implement is what you implement. And that is a step that is, I would say, it's not, it's lacking pretty much everywhere. You want to take this, or should I?
You should do it.
This is just one of my favorite things when it comes to programming. When I was at university, I was only coding for myself. Doesn't really matter what the code looks like. And lots of people, I don't, probably a few of you, think it's the coolest thing you can do is making a program that no one can read. You have to execute it to see what happens. It's kind of nice, but it's really not that nice to do in a project with more than one person. And if you're going to do an aircraft that will be flying for 20, 40 years, at least someone will look at your code. So we have to just make it readable. Like, is it easy? How many of you use comments when you're coding? Is it good to use comments in the code? If you would make the code readable, would you need the comments? Can you rewrite the code so you don't need the comments? What I usually do very often is like when I was coding before, I was always making comments like I should do this, then do that, blah blah. Then very often it's very easy to just remove the comment and make the comment as a name of a function. Then you get very far just doing that. Golden tip. And then naming convention. I mean, that's depending on what project you're working on or what company. Making the functions small. I worked in one project we had 10 lines was the max. We were not allowed to have a function more than 10 lines. Like, is this good or not? Maybe. Same extraction levels. That means that you should not say get this data, and add them together. Like, because then add them together should be a function that adds them together. Like, so you keep the abstraction. Otherwise, it can be really messy to see actually what is happening. And does anyone see a problem or something that could be a problem in the last line? Should I just pick someone? Are you using C or C++ when you're coding? No one sees anything that could be a problem? Ah, here we go. This was a perfect comment because this was not what I thought of, but it's very true. What I thought of was that the X will be a pointer, but this will not be a pointer. Because in C and C++, you just so usually you can either you push a star here, but I would really use different lines. So you have one line for int star X and one int for Y. Because here if you are new to programming or you just don't think of it, I mean, it seems like both of them will be the same type, but they will actually not be the same type. But nice comment, because it's also very true.
Yes, and since in grep and CD, that's been around for about 15 years now, I can really sign to this because we have old code. And there's been different generations of programmers that made the code, and a lot of times you don't understand what they've been doing. And also, when they started out with the code in grep and C, it was in Swedish. So somewhere after about 5 years, they changed the language. They just swapped all the variables, took one variables and said it was equal to a English variable, and now you have to look for where does that happen, because some of the code and some of the functions are made in Swedish, and you get some results, and suddenly it just continues in English, and you don't see when and where it happened. Sometimes you have to call in people who are retired to ask them what they've done or didn't do, because some of the documentation is also just as bad as code.
Yeah, so this is not, of course, any commercial for Saab, but we do have these cool simulators. And you can fly there, getting paid.
Yeah. Flying around during work hours. I did that today, actually, for about 4 hours.
The first time I was flying there, I actually went to Forshaga, my old town. It goes a lot faster than going by car. It's like crazy much faster.
Yes, and something special about Saab, we have these simulators on desktop, so we can test the code directly.
Immediately, yes.
Immediately.
At your own computer, you can start it up. Of course, you don't get this super cool dome, but it's nice to have it the possibility to test. You know, as a programmer, I would say I like it a lot. Then here we go pretty much on these different levels, if it's flight critical or if it's just mission critical, or if it's just something nice for the pilot to have. We have some different levels. And this is of course a decision that might be difficult to take for some companies. But again, for airplane you don't have the option really. So if you feel that, okay, here something can go really wrong. So if you remembers was it like 3 years ago? There were 2 airplanes crashing, not Saab, some American airplanes. What they did actually was that there were so many things, but one thing was that they didn't want to to get new training for the pilot, and to stop that from happening, because it would be so expensive for the companies who buying the airplanes. They made the plane to look like the old version, and then they can say, no, it's the same airplane. So if you can fly the old one, you can fly this one. And to make that happen, they had some some functionality that actually put the nose down a little bit. And since the pilots didn't get any training, they didn't know that the nose was going down. And they were thinking like, if we make some functionality that automatically puts the nose down without the pilot knowing about it, could this be dangerous? Nah, that would be very expensive to make that. So, but what should have happened was that if you see that this is really difficult, or not difficult, if you can be, you can actually die, or you go down, crash, then you have different ways of testing the code. So one thing is that you test every line of code, or you can test all the decisions. Like if you have an if or else, then you make sure you go into this if, and you go into the else. And then you can also have, if there are multiple things that makes, if it's like if this or that, then maybe it's okay to just test one of them, because then you test all the lines of code. But you can also make sure that you actually trigger all the decisions. So if it's this or that one, then you make sure you test that one and that one. And also you test all the inputs for a normal range, which is what should be possible. And then you have a robust range, is something outside. This should not happen, but let's still test it. So what we do in this scenario, we have said that if it's less than 1.5, it should be closed, something. If it's above 1.5, it should be open. So what we test is we take just a random number here, and take the small or the highest value that is with a less than 0, and then you take the 1 that is actually not here. You should have 1 also that is just above 0, and just take somewhere in the middle, and then here you take the smallest possible you can do before this one, the smallest possible after this one, and the same here. So that is how you test, to make sure that everything is tested and verified. And what can easily be missed is the ones that are outside the boundary, because you think, it cannot happen. Do you have something to add?
Yes.
Great.
Well, the testing starts with us. We test in our own simulators, the desktop simulators, and then we go to the bigger simulators, the full rigs, and then we do the full rigs together with pilots, and a lot of testing there before they put it in the test aircrafts. So there are different levels of testing before they actually fly.
And they also do a lot of testing while flying.
Yeah.
It's also quite fun, because you can tell the pilot you should go like this and that and that, and then you can go outside the window, or you go to the window, you see, and then you know 3, 2, 1, here is a lot of G-force. Okay, should we do some more tests? Who wants to say a mistake first? Because it's easiest in the beginning, because then you have 1 out of 3. Huh? Sorry?
Sorry. Sorry.
B is 1, I think, in this case.
This is just, it could be a lot of codes before, but why is this wrong? I mean, whatever value you have on A. Let's say A is 1. What value will you get on B?
I'm not quite certain in this case, because I don't remember which takes precedence, if plus binds more strongly than minus in that case. Thank you.
If we are talking about C or C++, this is not defined, so you don't know. If you take this one first, then of course you will add 1 to A, so it will be 2. But if you're reading this one first, it will not happen. So you don't really know what will happen there. The second one, more difficult to read. Do you see what we are trying to to make not happen? This is a problem if you have 17 divided by x. You don't want x to be 0. So, of course, we just check that x is not 0. The problem with this is that it's not defined if you do this first or that first. If you would if you know that this is done first, then you're not sure. Then you're sure, because if this one is 0, then you already know it's not true. So then you don't even care about this one. But it's not defined in a language, so it could be this one doing first. So, and then of course it doesn't help you at all if you have checked if it's 0 or not before, because it's actually not happening before. And this one you have from normal math. It's not defined either. So will you multiply A with B first, or will you divide B with C first? Also, we don't know. Here, more tricky. More points. Who wants the points? Let's ask again. How many of you are programmers? Fewer. Which language are you using, by the way? Usually. Python? Pascal? So C and C++ is dead? Is that what you're saying? Damn it. So what we're doing here is that we say we have a character C. We just put it any letter. Doesn't matter. The problem here is that we only have it's 8 bits, I think. But then we cast it and we say into an integer, which is 32 bits. And to an integer you can put a very large number, of course. It's 2 in the power of 32. And 256 is with no problem for an integer. But since this is just a pointer, so it's actually the memory that we have actually allocated is just 8 bits, and then this is too big. So here we crash.
Okay, I think we're almost out of time. Sorry to stop you there because we have another presentation.
Yeah.
And I think perhaps you're going to be around for the mingle, so for any questions. But big thanks for the presentation, and yeah, we'll talk to you later.
Thank you.
Thank you.
So now we will have Casper. So we welcome Casper to the stage for his presentation. Welcome.
Right. Thank you very much. Very good. I will put this in my pocket like so. Turn this on. Turn this on. Hopefully this works. Like so. Why did it not connect? Because the HDMI is out. Right. All right. We now have all right. Sorry, I'm right. So my name is Casper. I'm going to talk about types for the next 15 minutes or so. Just because everyone talked about themselves for a short while, I will also do that. I'm a student in my 3rd year at the computer science program at Linköping University. I have some passing interests in programming in general and other stuff, but also in nice typesetting, which is especially relevant to this talk. So, what is types? Has anybody heard of it before here? No. Very good. Then at least I'm reaching some new people here. So types is basically LaTeX for the 21st century, if I were to sum it up in one sentence. Are people here familiar with what LaTeX is? Yes, very good. Very good, very good. For those who are not familiar, it's basically a programming language where you program PDFs. In very, very short. It does more than that, but it's that's the gist of it. This is something of a replacement for that. Types is something of a replacement for LaTeX. Excuse me. So there are some issues with LaTeX in general. First of all, you have the very, very old syntax, which you have to work around. You have to call begin and end on things, and it's quite irritating to do. In many cases, you want to make a bullet list, you have to write \begin, enumerate, and so on and so forth, which is not very nice. Another problem is that it can take a very, very long time to compile, especially for longer and more complex works. So a person I know had a master's, how do you say it in English? He wrote a very long scientific paper, and it took him about 90 seconds to compile. So every time he changed something, he needed to wait for 90 seconds for it to finish. Another issue is that you need to recompile documents multiple times because it goes from top to bottom and cannot build some stuff. It cannot build the table of contents before it knows the contents. So it needs to go through things multiple times. So it tells you, oh, I didn't quite finish. Please recompile me 5 more times. This is not optimal, to say the least. Another issue is that it lacks some basics in just the standard distribution, so you don't get code highlighting built in, you don't get reference handling in the basic distribution, and this means that you need to use loads of packages. And these come in gigabytes of dependencies, which you need to download. Anyone who has ever tried to compile TechLive, the full distribution, knows that it takes, I don't know, 30 gigs or something. It's huge. Another issue is that there's no real standardization of interfaces. So every package has its own way of doing things, its own external programs, which you need to run on it to get it to compile and work for you. And finally, some very, very nice compiler errors. This is an actual compiler error. I will read it out for those who may not be able to read this. It says, if you really absolutely need more capacity, you can ask a wizard to enlarge me. Any guesses as to what this may be? Yes, it's an out-of-memory error. You are exactly right. It's not really straightforward. It could have said that it just ran out of memory, but no. So yes, Typed is tries to solve many of these things in its own way. It first of all was launched in around about 2019 for the first version by 2 German guys, Martin Haag and Lawrence Madje. They built into it higher level functions like loops, iterators, lambdas, fun stuff like that. So you don't need to rely on macros for everything. They made the syntax much more modern, so it's quite similar to Rust for all of the scripting which you need to do, and you use kind of markdown-ish characters to indicate bold text, italics, and so on. You have a lot faster compiler, so most documents compile in less than a second. In their web app, which they have, you can basically write and it live updates, so you don't need to recompile every time you make some change. Another thing is nice helpful error messages. So if any of you have ever written any Rust, you may have noticed that if you, I don't know, try to add a float and an integer, it complains at you and basically draws an arrow in ASCII that, oh, you're doing something wrong here, please change it to this. Yeah. Types also does that. Not quite to the same degree, but it's constantly getting better, and it's already very nice in my opinion, at least. Another thing, it's a batteries included language, so you have things like handling of references, you have things like code highlighting just built in by default. Further, you have a very extensive set of packages to do things which you can't do in the standard distribution. So complex figures, graphs, diagrams. There is a package to do guitar tablature for anyone interested in that. And it has some company backing. There is a company developing this. Their business model is basically, we provide the language as free software, so the compiler and everything is, if I remember correctly, Apache 2.0 licensed. But their web editor, which they also provide, kind of looks like Overleaf, for those of you who know that. It's that has paid features if you want to use some special things like comments in the Google Docs style or other such things. So yeah, here is a quick cheat sheet of how you do things. So on the left you have what things do. In the middle you have the LaTeX equivalent, and on the right you have the types equivalent. So headings are just indicated with equal signs and a space. The more equal signs, the smaller the heading. So 1 equals is a top level heading, 2 equals is a second level, and so on and so forth. Strong emphasis or bolds are made with stars, italics with underscores, raw text with backticks. If you do triple backticks and write a language hint like Python or TYP for types, it does automatic code highlighting, which is very nice, and a code block. This is how I did the LaTeX. You can see an example of this. It's a bit janky on the right because this is a presentation framework I'm using, but yeah. Labels are done with chevrons. References are done with an @ further, citations are also done with an @ It supports bib.latex. So if you want to use that, you can just take your file and it works. The default citation is IEEE, so it's very nice for us engineers. A bullet list is done with just a dash and a space, and you just build up on that and it makes a bullet list. Enumerations are pluses. Term lists are, you can see it's a slash, the term, a colon, and then what you write afterward. Math is quite similar actually. LaTeX already does that really nicely in many ways, so they just made it quite similar. Note that if you put spaces between the dollar signs and the math characters, you get a math block. If you want to space things out, that may be something unexpected. So you have loops and variables, for instance. The let keyword tells the compiler to assign a variable. So in this case, text is assigned to the string I equals. Then you get a for loop. So this looks quite a lot like Rust, where you get for I in the range of 0 to 2, range to n-1. And then you put the text and the I. The hash basically tells it to, instead of writing text, just dereference a variable. And the backslash is a manual new line, so I don't have to put a just blank line underneath here. The output can be seen as such. You can do images and figures very well. I'm sorry about the contrast ratio here, but that's LaTeX logo put out. You have a figure function where you write a small caption and provided some content, in this case an image, which is loaded. Yeah, and underneath this is a label, so here I refer to that label and it automatically numbers it. It's really quite nice. Lastly, you have functions and lambdas. The first two lines are equivalent, so you tell it to assign a lambda which takes two things and returns their sum. Also here, function which takes two arguments and returns their sum. In this case, we may call them with different values and get the following output. Right. You may have variadic functions, which is very nice if you want to, say, load a table from CSV and just generate a table. If you run linear regressions on a bunch of points and you want to do things, that's very nice. So here we take make a formatting function which takes a title and a list of authors. We iterate over the authors and join them together with commas, and for the last one an and. I took this from the examples on the website. So here I put in my name and some other names, and they came out like this, which is quite nice, I think. I am sorry if it is going a bit fast, but the meaning is to just show a bit of the features. Feel free to look at this in your own time at any later date. Also, there are set and show rules. Sorry if this is a little small, I tried to fit it on one slide. So set rules basically tell the compiler to, whenever you call this function, just set this default variable. So in this case, we tell it to use the font New Computer Modern, which is the default for tech, and at size 17, and you get the following texts by just writing normally instead of having to explicitly call the function with the parameters. Show rules are a bit different. They tell the compiler to wrap an element of a type in a function. So here we tell it to wrap a link in a gray box, as can be seen. Yes. All right, so some examples. This is the LaTeX version of a bullet list. Should be familiar to most people. This is the typed version. Much closer to the just raw text as one would imagine it. So in most cases you can just write a text document which just looks like plain text or looks like markdown and get nice output from it. Some examples of math. You may see here that you have dollar signs to create a math block. Then the integral, you may assign integral to a shorter name if you're using it a lot, because it works just as well then. Underlines for subscript, carets for superscript. One little problem which some people don't like is that you have to write spaces between singular letters, otherwise it tries to find the function dx or the variable dx and dereference it. But this can be you can just write a function which makes this a bit nicer. I will show you later. This is an example of just how you would typeset the Dirichlet function. So it's 1 if x is rational, 0 if x is irrational, and you have 1 subscripted by a blackboard text q. Double capital letters make a blackboard text. And then you have a cases function which takes just a bunch of lines and creates a left brace on them. You may notice that the in variable here has a .not, and that's because most variables act like this. In most cases you can just make a dot and you get many different variants of a variable instead of having to remember every single abbreviation. Of course, nothing is stopping you from making an alias. So on to packages. Physica is a quite large package which provides a bunch of semantics for writing out math and physics and formulae. So an import is done as such that you write #import and then a string where you put the version of the package in. So if someone updates the package and that breaks, your document doesn't break because you're still relying on the old one. And if you want to upgrade, you're free to do so at your own time. The glob operator just tells it to import everything from the package. So here we have, we make some math. Here you can make matrices which look nice. You can make determinant matrices and so on and so forth. Some math students here who have to take notes during math class may be happy to know that you can just tell it to make a Jacobian of something or a Hessian or other things. and it just does it. It auto generates it. So here we tell it to make a Jacobian of f subscript 1 and f subscript 2 with variables x and y. We give it a matrix. It puts out the Jacobian version of the matrix, and it's very nice. At least in my opinion. Here you can tell it the delimiter. You may set this with a set rule, as shown earlier. So where I set the text font, I can set the standard delimiter to be this, which is quite nice. Further, sets is like text but for types. I did not show code here because it's quite a lot. I think it's about 70 lines of code here to make it look this nice. But you can certainly get by on shorter things. And in most cases you don't use sets directly, but you use some smaller package for a more specialized field. So some other examples of sets diagrams. It's quite powerful, and it's, in my opinion, easier to use than ticks. But it's not yet as mature, so some things are not yet supported, but it's very well documented and it's constantly improving. So yeah, I like it. It's nice. Right, Fletcher is probably my favorite package. It is basically used for drawing diagrams with nodes and arrows between them. So to explain this, you import it, and this is very small, I realize, but to basically how you do things is that you write a node at a location. You don't have to specify the location, then it tries to figure it out on its own. It can do that to a degree. In this case, it can, so they tell there should be a G, and it should have an arrow that goes to the right, which is labeled F, to a node called im of F, or image of F, and so on and so forth. And in 4 lines of code, you get something like this, which is really quite powerful, in my opinion.
Casper,
yes?
I'm sorry, but we're going a bit over now.
All right.
So.
Oh, I apologize. 2 slides left, or some such. Yeah, this is a Find Mine diagram. This is some other thing I wrote, and this presentation is written in something called Toying, which is a really quite nice presentation framework. All right. Yeah, no time for questions, but you may approach me.
Yeah,
later.
exactly. I think ask questions to Casper during the pizza and drinks.
Right.
Thank you so much for your presentation. I'm so glad you were able to present for us. So thank you. Right. And very soon we're going to go to get pizza. It has arrived, but I promised we have Sister Skopet here. They want to introduce themselves because they're interested in collaborating. So yes, the mic is yours.
Yes. I think one is fine. We can just do one.
Okay.
No. I'll keep it very brief. This feels odd, having a microphone. But hello, everybody. Thank you for the very interesting projects presented. So my name is Elise, and besides me, I have Stella, Magda, and Tilda. We're part of Systerskapet, which is a small female organization within the program of Information Sciences here at the university. Our purpose is basically to strive for equality within the IT business, and we do so by engaging females. No, other students as well, but specifically we try to engage females in different kind of events. So when Uli invited us here today, we saw it as an amazing opportunity to experience an event here, and also, I want to say, investigate interest in a future collaboration with us and Go to 10 at this amazing venue. So yeah, thank you, Erin and Uli, and for all of you for listening. Yeah.
Thank you. Yeah, you can set that down here.
Yeah.
Okay, so you can talk with Sister Scarpet also as well. I'm going to just about to let you go now because I know you're probably all hungry and want to get some drinks. But before we go, I would really love it if we could just take a group photo, like all here, and then we can all go and have pizza and chat. And I also wanted to just have a final thanks for everybody. For the event, for you for turning up for the event, and also thanks to Saab for the presentations, and also thank you for providing the food and drinks as well, and thank you to Casper for your presentation as well. And yeah, I think that is all I'd like to say, but yes, that's the end of this part, so we're going to take a photograph, have some pizza, and we can chat some more. So thank you, everyone.